Greetings, this is Artie from Artifact Electronics. I got me some pinball machines, and I figured we'd go through them together and get them up and running. None of the boring stuff like cleaning play fields and putting rubber rings on and using several bottles of Windex, but concentrate on the electronics that are ill and see if we can play a game real soon on this thing. When I got it, it powered up at the seller's house. It was several hundred miles away from here, but you couldn't start a game. You could credit it up, but when you hit the start button, nothing would happen. And normally the games will complain. They'll say you don't have enough balls in there, or add this or do that to be able to start a game, but this one didn't say anything. It just plain ignored me. And I did some work on this because I wasn't really planning on doing a video, because I thought, hey, change a couple of things and you'll be done, but no, it was not that simple. So I thought, let's film the whole thing, at least the electrical parts, and see if we can get this guy up and running. I did a bunch of cleaning on it. The legs were filthy. The leg levelers were rusted and filthy. I didn't even want to bring it inside the house like that. So I did do some preliminary work in the garage cleaning things up, and brought it in, put new leg levelers on it, stood up the machine, and just generally got rid of the worst of the dirt. Playfield doesn't look too bad. I'm guessing the seller wiped it down before I got there. It's clean, doesn't seem to have any wear, but it's missing most of the rubber rings. There's still bits and pieces of them left, like down there you can see some, but they're all torn or rotted. Flippers don't even have anything on there. But as mentioned before, the original problem was that I couldn't start a game on it. And the problem with that was, normally on these games when you want to start a game, and the main reason for it not wanting to start is that there are not enough balls in the game. It does tell you over here very clearly, install. Well, it looks like a 2, but it's not a 2. That's actually a 3. It needs to have 3 balls in it to start. And what the machine will do if you don't have 3 balls and you try to start a game, it'll just say, hey, it'll start a ball search. Kick all the solenoids, try to get balls out of stuck places and stuff. This machine just sat there, didn't make a peep. I had it credited up, but pressing the button gave me no response whatsoever. The problem turned out to be the gun we're looking at. The ball rolls in there and then it starts swinging out, and the purpose of it is it swings out and then a bunch of targets light up under the silver ship, and you're supposed to hit those buttons and you get lots of points if you hit it. But the problem was the gun wasn't rotating, and what had happened was it wasn't at its home position. So the game was kind of sitting there waiting for the gun to return to the home position, which it didn't tell me, of course, but the gun wouldn't move. So it just sat there forever, not doing anything. That problem has been fixed, and I will explain how I fixed it. But let's turn on the machine and see what it tells us. So what it's saying, factory settings restored, and yeah, the dot matrix displays outgassing. That's also bad. See if I can stop the gun is trying to calibrate itself right now. So I'll stop that. The sound is really, really, really thin. Now it is supposedly tells me what's wrong, gives me the test report, but all it's really telling me is time and date are not set. And what that means is that there are backup batteries on the board that saves all the settings, and those batteries are dead. So it factory resets itself every time you turn it on and plays with the defaults. And you can set the defaults, but of course the minute you turn off the machine, it forgets them all. Yeah, that sounds really bad. I think one of the speakers is gone. But let's have a look inside the cabinet, see if you can see anything obvious there, and then move on to the brain cavity. So here she is with the hood open. We can see lots of lights blinking. Absolutely filthy inside of the cabinet. Let's see. It was built on October 8th, 1991. So inside the cabinet, got some interface boards here, the coin door with the buttons to control things and get into menus, a rather large transformer that has many secondaries and goes straight to the power driver. So there's really no power supply board in here, a separate power supply board. It's all handled on the driver board. And then the speaker that I think is dead, especially since that grill that's supposed to protect it. When I set up the machine, I noticed that the grill was kicked in. So probably the cone is ripped to shreds on that thing. But that's an easy fix. Now, as far as lights are concerned, there are three kinds of lights in this pinball machine. The first type are called general GI or general illumination. And those are lights that are generally tied to the transformer directly. They light up the playfield and the backglass and all of that. And they usually come on when you turn on the machine. Now on this machine, none of the general illumination came on. I mean, the backglass didn't light up. The playfield is lit up by the lights you see flashing, but none of the static lights are on. So the flashing lights are the second kind of lights. They're called control lights, and they're controlled on a per bulb basis by the computer. And then this one also has a third kind that are high voltage flashers, such as these. They run off like 18 volts or 20 volts. And those we'd have to go into test mode to see them flash. But what is evident right off the bat is that none of the general illumination works. So let's have a look at the brains. To give you a better idea of the lights, or lack thereof, we're looking at the back glass, and we can't see Arnold, because that is supposed to be lit up with general illumination, and that doesn't work. The playfield's dark, and the only thing that's lighting it up are the controlled lamps. There's supposed to be a bunch of lamps on the left and right that are always lit, and those are gone. So all of that stuff is gone. The display does work, but it does show signs of beginning to outgas, which means it's going to need to be replaced. All right, let's see what the electronics have to say. And here are the electronics. On the left, with the blinking LED, is the CPU board. And we'll look at that. We'll look at that in more detail because it's got to come out. You'll notice there's a battery holder that's empty, but that's because I pulled the batteries and I checked the batteries. They were nearly brand new. So somebody realized that wasn't working, put in some new batteries, and then saw that, hey, it don't work. Then on the bottom of the board we have all of these connectors. That's the switch matrix, and we have a bunch of other cables going to the big guy, which is the power driver. Right there you can see bridge rectifiers and transistors and all sorts of good stuff on it, and many connectors. Thank you. And then we can see several messes over here. Usually happens on these machines because they're on 24/7 for years at a time. These connectors burn up, and obviously did a real bang-up job here of replacing stuff, which is probably those actually, these are the GI connectors over here. That's one end of them, and this is the other end. And what was done here is it looks like two signals were taken and wrapped into one. Really nice job here. That's going to need to be redone. Oh, and another thing I didn't mention on this machine, remember I said the GI lights are tied to the transformer or on all the time? Well, on this machine that's not totally true, because there's like 6 sections of GI lights, and they have SCRs in here that the computer can use to turn on and off the GI. So they can make the whole machine flash and make it look fantastic and do all sorts of neat stuff with it. So the possibility is, I mean, if the GIs on this were connected directly to the transformer, I'd be in trouble because I'd have a transformer problem. I've already did check the fuses, of which there are plenty. But what I think is here we're having either connector problems or we are having problems with the SCRs, especially after I saw that some of them have been tied together. And that can't be good. But anyway, to finish the tour, on the right side we have that's the display board. It's kind of interesting. It's driving the dot matrix display, and it is a video card for all intents and purposes, except it's made out of discrete TTL chips, and then it has a high voltage section underneath that provides the plus minus 100 and something volts that the display needs. Those high voltage sections we're looking at, those always go bad. This stuff is badly under-specced, and things just burn through the phenolic board. And in the middle we have which is kind of obscured by the cables, but that's the soundboard in the middle. And that's independent, has its own processor on it. And that sums up what's in here. Notice again, there's no real power supply boards or anything like that. Everything comes in, I think it is through here. Actually, there's several spots where the power comes in, and everything is regulated and adjusted on the driver board. Now, remember, the game wasn't starting up, letting me start to play a game, because the gun couldn't adjust itself, and it was sensing that the gun wasn't in its home position and didn't let me do anything. So I followed up on that to see what the problem was, and this board has convenient LEDs on it to show you which part of the power supply on this board actually works. They're not accurate by any means. They're simple go, no-go indicators if the voltages are there. And one thing that I noticed after looking at the schematics, the LED right in the middle of the screen, that is the 20 volt LED, and that wasn't lit. And guess what? The motor on the gun needs 20 volts. So boom, that was the first problem. And let's have a look at how that got fixed. 20 volt regulation, or the conversion, I should say, part is really, really simple. It's not even regulated. It's just AC to DC conversion. But we can see this is where the transformer is, one of the places where the transformer plugs in, the secondaries. And we see this one line going through, what is that? Through this fuse, going to one leg of the AC input on the bridge. And then the other leg feeds the other end. And then what we have on the negative DC output, this goes down and it connects to the ground on the board. And this side simply comes out, has a smoothing capacitor, 15,000 microfarads, 20 volts DC, goes to test point 7, and here's the LED I showed you that wasn't lighting up. So how hard can that be to fix, right? Well, there's really not a, well, there are a few things that can go wrong. Obviously, worst case, well, best case, the fuse is blown, which it wasn't. Worst case is that the transformer secondary is bad. And then there's not a whole lot left. It's the bridge rectifier and the cap. And I guess you can just throw a parts cannon at it, but you know, I'm curious minds want to know. So I dug into it to find out what exactly was wrong. So here's the affected area, and I guess that's already given it away. But this is the bridge rectifier, and this is the smoothing cap. But there were several things wrong with this, because the bridge rectifier had been replaced. This guy over here, no, this guy. And when tearing out the old part, basically 2 of the vias got ripped out. And the vias in here, let's see if I can show that. See this blob of solder here? It was going through this hole and connecting to the backside over here, but not connecting on the top side. And it was expecting the bottom to be connected to the top through the leg of the rectifier as well as the via, but when I did some measurements, continuity measurements, I noticed that the power was not getting, there was nothing on this leg. It just wasn't getting any power, and I reflowed the solder and it still didn't work. So I hardwired it over here, and I said, okay, I found the problem, and I put it back in the machine, turned on the machine, and this fuse, which is the fuse we saw in the schematic, blew immediately. Alright, so I went in there, I did continuity checks, and the DC output of the bridge and ground were at a dead short. Well, it didn't leave a whole lot of guesswork. There wasn't a lot of room left over in here of what could possibly go wrong. I mean, I measured it on the board, and yes, there was a dead short. And yes, here's the bad guy. And I didn't even need component tester to verify this. All I needed here was a continuity meter. And just as you guessed, it shows a short, but let's see what the actual resistance is. 0.001 ohms. Can't find a better short than that. So I replaced this cap, reinstalled it in the machine, the 20 volt LED came on, and the gun started to go into self-calibrating mode. But one of the problems at that point I realized was, and that's probably when I made the decision to start filming this, is that every time I power cycled the machine, it lost its mind because the batteries weren't working, and so the next time I turn on the machine, it would start to calibrate the gun again, which was loud, and it did like 10 passes or so on the gun, swinging it back and forth every time you turned on the machine, which got old real fast. So I figured the next thing to do is let's find out what's wrong with the battery holder or the battery circuit on the CPU board, and see if we can fix that, and then put everything together and at least see if after calibrating itself it'll remember the calibration and you can just start the game normally. Here's a CPU board. It's got a 6809 on it, large EEPROM, static RAM, big gate array, proprietary, that is used to generate all the I/O signals, because this is a connector that it talks to the driver board through. And down here we have all of these connectors that are the switch matrix. And then we got a couple of nickel and dime things over here, and the battery holder in the middle. Now upon closer inspection, it shows us, I don't know if you can see that, but there's a fair amount of battery leakage on this. I don't know, the camera doesn't make it very clear, because these almost look the same, but there's a bunch of battery alkaline on here that's probably preventing the battery from making any contact at all. So let's see if I can clean that one up. I'll clean all of them, but there's a little bit on this one too, but I'll clean all of them up using some vinegar followed by some IPA to neutralize the vinegar. And then we'll put batteries in and just measure this thing on the bench and see if it's actually supplying backup voltage. So what does this circuit look like? Equally uncomplicated, just as a 20 volts. We got a set of 3, what are these? AA, triple A's, no, double A's. In series, one end is ground. The other end goes to a diode. It's most likely a Schottky. No, actually this isn't. This is a regular signal diode, so it drops it by 0.6 volts and puts the battery voltage on here. And from the other end, when the machine's on, we get VCC, which is 5 volts, coming through this diode, which is a Schottky diode. And the reason they use Schottkys in these cases is because the forward drop is much less than it is on a regular diode. But I guess the regular diode is on the battery side, and these both end up on this line, which is called VBAT, for voltage for the battery. And the way the backup basically works on this is that there's always a voltage over here. When the game's on, you get full blast 5 volts. That's why they have the Schottky, so they get us close to 5 volts. So the static RAM operates in normal operating mode. And here we have, 4.5 volts with a 0.6 volt drop. So we have about 3.9 volts, which is enough to keep the static RAM alive when this power is removed. So now let's check the board. So here we are after cleanup. This guy over here, the vinegar kind of took care of most of the green crusties, and then there was some rust underneath that I took off with a small file, and then basically bathed the whole area here in IPA and let it evaporate to neutralize and get rid of the vinegar. So now we need batteries. And being the thrifty kind of guy I am, I'm actually going to reuse the batteries that were in there. Why would you want to do that? Because they're brand new and I don't like to waste things. And I'll prove that. And this is it's an actual battery test mode, so I'm assuming it's putting a small load on the battery. Yeah, these things are brand new. So I am going to use them. Now, one thing that I'll probably get some comments on is a lot of people advocate taking this battery holder off, getting a regular 3 battery holder and mounting the whole thing off board. And even though that does kind of make sense, because one of the problems is where I got lucky is the board sits like this, upright. And when the batteries start leaking, they start leaking on these components down here and wreak havoc. In my case, I was very lucky that it was only on this contact. Nothing leaked off, nothing else got hit. There's no crusties on the chips below. And so in general it would make sense to move this away, but why? I usually put a sticker on my machines when I last change the batteries and check it on a 6-monthly basis and replace the batteries probably after 2 years or so, or even less. So generally batteries do not leak in my environment, and I'm not going to disfigure this and put a wire on it and hang some battery holder underneath the machine. But if you really want to be sure about it, go ahead and do it. Mount the battery holder with some Velcro on the bottom of the back box, and even if they leak, the worst that can happen is you need to get a new battery holder. Now also keep in mind though that in really bad situations, when the battery is leaking for a long time, the battery leakage will actually move up. I think it's the negative wire or the positive wire, I'm not sure, and come right back to the board and start corroding stuff that's on the board. So even that approach isn't 100% safe. The only safe thing is check your batteries every few months and replace them when they start showing weakness. All right. Okay, batteries are in. Let's see what we got. Ground is on this end, and the end of the series chain of batteries is here. Read as 4.46. That ends up on one end of the Schottky diode over here. Same value. Should see a drop. Oh, sorry, that's not a Schottky, that's the signal diode. And we see a drop. What was it? Of about 0.45 volts. That's because there's really not a whole lot of juice flowing through it. And finally, what we do is we measure this at the SRAM. And we see 4 volts appear at the SRAM, which should be more than enough to keep it alive when power is removed. Now, of course, the only way we can find out is we got to reinstall this board, and we got to reinstall the power driver board and see if it actually maintains its memory now. Okay, I got the boards back in. One piece of advice when you're removing these boards, especially the power driver board, take a picture. It'll last you longer. Even though we have wire memory on all of these connectors, they're all supposed to be keyed. Some of the keys have disappeared. Some look similar. Just take a picture of this thing so when you're putting it back together, you'll thank yourself. Okay, ready for the big test. So it should again come up and tell us factory settings restored. And that's fine, because this is the first time it's coming up with batteries that hopefully work. You see the gun's going bananas. I think it's calibrating itself. But I don't want to wait for that. I'm still curious, so I'm going to interrupt. Okay. Okay, let's turn her off. Actually, what I'll do is I'll go in and I'll set the time that it's complaining about, and then the next time when we turn it off and turn it back on again, everything should be good. This is going to take a while. I don't know why it needs calibration. I mean, there's a couple of switches in there, but I'm sure there's a really good reason for doing this, so please wait. Okay, she's been sitting for a while. Let's see if the battery voltage took hold. No more complaints. Looks like the battery mod worked. So we did a bunch of things today. We got the battery to work, and we got an explanation of the gun, or why that wasn't working, because of a lack of 20 volts. And it's probably enough for this episode. The next episode we'll actually try to play a short game to see, I mean, if it'll start a game. And even though the playfield needs a lot of work, the rubber rings are missing, there are just things broken, but it should be enough to show us if we can if we can kind of play through a game, and that'll give us a much better impression of how much farther we're going to have to go with this game to get it fully working. Thanks for watching. Thumbs up would be appreciated. And leave me a comment if you've gone through the same thing as I have, and if you have any good advice for what to do here. And make sure to subscribe so you don't miss the next one. See you soon.